Miss Ellery, and this is my teaching partner,
Ms. Alexander.
and we're here to help you learn science. I'm going to begin by writing a question on the board, students, that we're going to answer, and this is the question. Will it dissolve? Yes or no?
So what we're going to do is we're going to do thumbs up for yes and a thumbs down for no.
Okay. So, what does it mean to dissolve?
To disappear?
Well, let's see. Miss Alexander, can I borrow your finger for a second?
Sure.
Okay. Would you mind sticking your finger in this water, and we're going to see if it dissolves?
In the water?
In the water.
Okay.
Students, what do you think?
I still have a finger.
Okay. All right. Still there. Okay. Well, let's see. Let's test it with some salt. You want to try that?
Okay.
Okay. Here we go. All right. I'm going to put a little bit in, students, with my fingers. And then we can stir. Let's check this out. What do you think?
I don't see it anymore.
I don't either. So the salt does seem to disappear. Let's try it with the pepper. Here we go. All right, adding a little pepper. And I'm going to stir it. Okay. Oh, goodness. It looks a little different.
Yeah, it's just sitting at the top.
It's just, yeah, and it's on the stir stick. So, students, we tested Miss Alexander's finger and salt and pepper, and we were looking at dissolving. So today we're going to investigate other materials, and we're going to be able to answer the question of the day.
Which is, how do the physical properties of a solvent affect its solubility? And so what we're going to need for you guys to do is to write that in your interactive journal, and we're going to post that on the board for you.
Let's talk about some teacher things that will help you in the classroom. First of all, with the engage, one of the misconceptions that students have with dissolving is that the solute or the substance actually really does disappear. And you may hear that answer given to you, and you'll have to talk students through that and explain to them that it doesn't disappear. It may seem to disappear, they can't see it, but it's still there. So make sure during the engage that if that concept or that idea comes up that you address it. Also, initially, when you begin this lesson, they're going to see all the materials that to some of the students look edible, the pop rocks, and you have to really address that these are materials that are used in the investigation, and you might even want to say that these have been in a science lab for quite a few years and they don't want to put any of the materials in their mouth, even though they may look like something they've eaten before.
Now that we've written down the question of the day, what I'm going to do is I'm going to pass out this worksheet that says the solubility of sugar and pixie sticks. So now that everyone has their worksheet, there's going to be a cup of 2 cups of cold water and 2 cups of warm water on your table, and 2 packets of sugar and 2 packets of pixie sticks on your table as well. And we're going to use our job cards, which are already on your table, and we're going to take a moment to let you guys read those to your group members. After you've read those job cards to your group members, the principal investigator and the safety monitor are going to make sure that they are watching the 2 cups of cold water. And our recorders and our principal investigators will make sure that they're watching the 2 cups of warm water. So for this part, each group is going to have 4 cups of water. There will be 2 cold cups of water and then 2 warm cups of water, and 2 packets of sugar, and then 2 pixie sticks, and 2 small miniature spoons. And so what we're going to do is we're going to have our principal investigators and our safety monitors monitor the cold cups of water, and then we're going to have our recorders and our technicians monitor the warm cups of water. And so since we have 2 spoons, the principal investigator will get a spoon, and then the safety monitor will get a spoon as well. And one of you will have a pixie stick and the other will have sugar. And I'm going to need for you to pour the same amount. We'll try to pour the same amount into your spoon. It may get a little messy.
I think we have the same amount.
Okay. So now that we have the same amount, what we're going to do is we're going to pour it in there, but not yet. Before we pour it in there, we're going to have to make sure that we both stir at the same exact time. So why is it important that we stir at the same time?
So that it's a fair investigation.
Correct. So on the count of 3, we're going to pour it in there, and I'm going to time it on the dot cam. So 1, 2, 3.
And we stir at the same speed, if we possibly can.
So we'll see which one is dissolving the fastest. Okay. And then we'll record our time. So now we're going to have our recorders and our technicians do the exact same thing. Decide which one will have the sugar and then which one will have the pixie sticks. And remember to pour the same amount of sugar and the same amount of pixie sticks. Same amount? It's just a little quicker. Okay? And we're going to reset our timer. And we're going to start again. So remember to try to stir at the same speed. So on the count of 3, we're going to pour it in. 1, 2, 3. Okay? So we're going to write what we observed and we're going to record our time on our worksheet.
All right, students, now we're going to do an investigation where we use pop rocks. And I know you've all had pop rocks before, and we're going to remember that we're not going to eat any of the materials today. We're going to use them as science equipment for our investigation. So to do this investigation, you're going to take the pop rocks and open it. We're going to demonstrate for you how to do this, and you'll put about 1/3 of it in each of these petri dishes. You should have 4 petri dishes. So you'll have 2 and you'll split them apart. You'll have a top and a bottom, so you'll have a total of 4. So we have the 4 petri dishes with our pop rocks in it. And remember, we're testing to find out what liquids will, which of these liquids will
Release the most gases.
So students, after you put all of your pop rocks in the 4 petri dishes and divided them equally, I want you to look at your recording sheet, and there's a spot for you to put what you predict is going to happen when we add the liquids of water, soap, soda, and oil to all 4 of the petri dishes. And I want you to write your predictions before we begin pouring the liquids. And we're going to walk around, and when we see that you have your predictions written, then we will begin the investigation. Students, what we're going to do in this investigation is you're going to pour each of these 4 liquids into the pop rocks, into the petri dishes, and they're in the order that they appear on your worksheet. This is the water, this is the soap, this is the soda, and this is the cooking oil. And you'll record your observations of the pop rocks before you add the liquid to it. And you can use the hand lens to do that. And after everyone has made their observations, then the principal investigator will pour the water, the technician will pour the soap into the petri dish, the safety monitor will pour the soda, and then the recorder will pour the cooking oil. So when you pour it in, you should make the observations. Each person should be recording on your sheet. If you notice, you'll hear the sound of the pop rocks. And now we're going to repeat with the soap. And the soda. finally, the cooking oil. And students, you should be recording your observations. You can use your sense of hearing, your sight, your touch, but obviously you can't taste. And then you should be ready to answer the question, which one popped the most, which popped the least, and why do you think the one popped the most that it did? During the Explore, one of the things you're going to need to monitor is making sure that students are recording on their observation sheets. Often they get very excited about the materials you put down, and you'll need to just monitor, walk around, and make sure everyone has recorded observations or made predictions before they begin using the materials you've put out. And that can be as simple as, asking them to give you a hand signal. Everyone at the table, when you're ready, raise your hand and I'll know that you're ready to begin, and I'll give you a signal to begin. Something to let them know that you're monitoring their writing and their ownership of what they need to write. During the Explore, you'll want to be walking around and asking them the questions that were written in the lesson. Things like, what are you noticing? What is your evidence? So monitor what they're doing. It's easy for them to get involved and forget the science behind why the materials are out. And so asking simple questions is a good way to do that. All right, so students, now that you've collected your observations, let's talk about what you wrote on your sheet. So what did you observe about what happened when you added the water to the Pop Rocks?
It started popping.
All right, it started popping. And how about the soap and the soda?
For the soap, it was popping really slow, but for the soda, it just started popping like crazy.
Okay, and what about the cooking oil?
It just sat there and got sticky.
Well, that's interesting. Let's talk about now why that might have happened. So 3 of the Petri dishes, you observed popping and the dissolving, but in one of them, you did not. So which one popped the most?
The soda.
The soda. And which one popped the least?
The cooking oil.
So students, what is your conclusion? Why do you think one of them popped more than the other?
Because the soda had more gases than cooking oil.
That's a good observation. And we're going to talk a little bit about why the Pop Rocks popped more with the soda. We're going to do a little background on how the Pop Rocks are made. Okay, students, so you just investigated what happens when Pop Rocks mix with liquids. And you shared some of the differences you observed. And when you added the liquids, the Pop Rocks broke down and they dissolved. And I want to tell you a little bit about how the candy is made. They make Pop Rock candy. It's a hard candy. They make with sugar and water, and it's made under high pressure. And they put it in a pressure chamber and put in CO2 gas. That's the same gas that's in your soda that bubbles. And when the candy cools down, these bubbles are trapped in there. And you probably saw those when you looked through the hand lens and looked at the Pop Rocks closely. And when you add Pop Rocks to your mouth, your saliva acts like the liquid, and it dissolves the Pop Rocks, and you get that sound and also that dissolving feeling. So when we dissolve one substance into another, we call that the ability to dissolve solubility. And I'm going to write that word, and I'd like you to write the word in your journals. Say the word with me. Solubility.
Solubility.
Good job, guys. Solubility. Okay? Make sure you're writing that in your journals. Solubility. You can see it's almost like the word dissolve too. It's got a similar part to it. So now we're going to think about any time that we record one substance in another, we're working with a solution. And you made solutions today. And the substances that you dissolve are called the solute. So let's look at this, students. I'm going to write the word solute. And I'd like you to write the word solute in your journal. Can you say solute with me?
Solute.
Okay. And I'm also going to write the word solution. We've used that word. So we have a solute is the part that dissolves. The substance that dissolves in a solution. And you should be writing this in your journals. And the liquid part, when you added the liquid to your Pop Rocks, the liquid part also has a name. And we call that a solvent. Say it with me, students.
Solvent.
Okay? And a solvent is the liquid, the substance, and it was a liquid in our case because we use all liquids. The substance or the liquid that the solute dissolves in. And if you'll notice, students, all these words have a similar beginning. So let's think about this. When you put your bubbles in the Pop Rocks, what was the solute? That's right, it was the Pop Rocks. And what was the solvent? That was the bubbles. And in all of your solutions, you had the oil was a solvent, you had the water, and you also had the cooking oil. But let's talk about the cooking oil, because the cooking oil did not cause any bubbles. So in that case, did you have a solution?
No.
You're right. When you get to the explain section, it's important whenever you use a vocabulary word like we use in this lesson, solute, solvent, solubility, that you write it for the students to see either on the board or a doc cam, and that you have students repeat it. And if you want them to write a definition, model writing it yourself for them. And again, you'll have to monitor that they've actually written it. Walk around, one of the partners can be walking around and monitoring while you're writing on the board. This is important. If we're using the vocabulary, we want the students to use it and to be comfortable writing it down. Any new academic vocabulary should be shared orally, have the class repeat it, and if you can make any connections between the words that would help them remember it, like with the solute, solvent, and solubility, they all have similar beginnings and they sound like the word dissolve, or they have a portion of the word, that would help the students also remember it during the explain. And make sure that you are explaining the science behind what they're exploring and asking them questions like, why are we using these materials? So students, we talked a little bit about gases that acted as solutes in the soda. So now I want you to think about why it's important for gases to dissolve in liquids. And I want you to think about it from the standpoint of being a fish. And think about how a fish has to obtain its oxygen. And I'm going to show you this image of a fish and how a fish obtains oxygen, just like all living things do. The fish has to take in its oxygen from the water, and the oxygen's dissolved in the water, and the fish has a special adaptation called gills that the water that's dissolved in the oxygen flows over, and the fish is able to absorb the oxygen from the water. And if you'll look at the graph with me, students, that shows the dissolved oxygen in fresh water, you can see on the side of the graph, it shows the oxygen solubility, and that abbreviation is milligrams for every liter. At the bottom of the worksheet, it shows, of the graph, it shows the water temperature. The elaborate part of the lesson, in this lesson, you may not be able to get to during your actual teaching time just because of time. But if you are able to do it, just make sure you're able to explain and make the connection between the dissolved oxygen in the water and the dissolving that they saw in their solutions that they created. So let's look at this graph and let's answer the question. How does the water temperature affect how the oxygen dissolves in the water, students?
If it's hotter, then there's less oxygen.
Okay, you're right. If you look at the graph, as the temperature increases, the line on the graph goes down, and that tells us that the amount of oxygen that's dissolved in the water decreases. So now, students, I want you to show us what you know. We're going to pass out a worksheet to you, and we'd like you to put your name on it and show us what you've learned in the lesson today. The evaluation part, try to avoid using the word test. Just present it as, let's show what you know. And it doesn't have to be presented like a test where they have to cover their answers. The object is that they learn something, whether it's helping each other or you're helping them. So present the evaluation as let's show what you know. And it's okay to help them if they ask questions during this time. If a student raises their hand and says, I don't know, it's okay to go ask them or go tell them.